Gemma 4 drops, and the community immediately gets to work. Google DeepMind's Gemma 4 family landed this week with something the open-weight community rarely gets: a genuinely competitive multimodal model under a permissive Apache 2 license. The lineup spans 4 sizes, from the tiny E2B 2.3B effective parameters up to a 31B dense model. But the star is the 2.6BA4B, a mixture of experts architecture with 128 experts and only 8 active per token, roughly 4B parameters per forward pass. The result is a model that achieves an LM Arena ELO of about 1441 while fitting comfortably on a 48GB MacBook Pro at 51 tokens per second. For context, reaching comparable ELO scores typically requires models with 400B plus total parameters. The smaller E2B and E4B variants also support audio input, making them genuine multimodal on-device candidates. All models support vision, text, function calling, and configurable thinking modes, with day zero support across transformers, llama.cpp, MLX, WebGPU, and Rust. The community response was immediate and practical. George Liu published a detailed walkthrough of running the 2.6BA4B locally using LM Studio 0. 4.0's new headless CLI LMs and Almster, which extracts the inference engine into a standalone daemon. No GUI required. On his M4 Pro with 48GB unified memory, the Q4KM quantization 1799G B delivers 51 TOC/S with a 48K context window and 1.5 S time to first token. Liu also integrated it with Claude Code via a local OpenAI compatible API, creating a zero-cost local inference backend for agentic workflows. His memory profiling shows the model fits at full 256K context within 3.748 GB, leaving headroom on a 48GB machine. The key insight for MoE models: skip speculative decoding entirely. It blows up memory bandwidth by loading the union of all experts across speculative tokens, with benchmarks on Mixtral showing a 54% slowdown on math tasks. Meanwhile, a community member discovered that swapping the F16 vision projector for Q80 loses no quality, and actually performed slightly better in some tests, while freeing roughly 30K tokens of context, enabling 60K plus total context with vision still active. And within days of Gemma 4's release, an obliterated variant appeared using adaptive refusal obliteration ARA, a 2-pass SVD technique that achieved the lowest refusal rate, highest quality score, and lowest KL divergence of any published obliteration of this model. 2 optimized builds are available: Apex IQ Q5KM about 20 GB, Ematrix calibrated for llama.cpp, and MLX mixed bit about 15 GB, tiered 468-bit for Apple Silicon, both with vision support. Full BF16 safe tensors and GGUF are also available. The full hardware spectrum. Galaxy Watches to V100 Racks. The on-device AI frontier keeps pushing lower. A Caltech spinout claims a 1-bit 8B parameter model fitting in 1.15 GB of memory that's competitive with Llama 3.8B on benchmarks. 440 TOC/S on a 4090, 136 TOC/S on M4 Pro, and reportedly about 40 TOC/S on an iPhone. If those numbers hold up under independent testing, a private LLM on a phone stops being a party trick and starts being a product. The skepticism is warranted. Benchmark maxing startups are a dime a dozen. But the architecture ternary weights, pure add/subtract computation is sound enough to deserve scrutiny. At the opposite extreme, a Samsung Galaxy Watch 4 Classic is now running small M2 360M thanks to a clever llama.cpp patch. The problem: the default model loading path maps the file into memory via map, then copies tensors into GML allocations, effectively loading the 2.70 MB model twice, peaking at 5.24 MB in a device with 3.80 MB free. The fixed passes host PIATAR into llama model params, so CPU tensors point directly into the map region, cutting peak RAM from 5.24 MB to 1.42 MB, 74% reduction, and boot time from 19S to 11S. The patch is heading upstream as a PR to gml.org/llama.cpp. A commenter's observation lands perfectly. In 2026, a watch has 380 megabytes of free RAM. My first computer had 80 megabytes of total hard drive space. And then, there's the lawyer from South Carolina who built a 10x NVIDIA V100 SXM2 server with 320 GB of VRAM, entirely orchestrated through Claude Code over SSH. His candid write-up: "This is just the corniest midlife crisis I could have ever had." Details the real-world friction of V100 hardware. No flash attention 2 requires SM80+. No GPTQ XLMAV2 broken on SM7.0. No FP8. And an NCCL dependency conflict where pip install E pulls in CU13 NCCL alongside CU12 PyTorch, silently breaking every multi-GPU launch. His benchmarks show command R32B at 35.2 TOC/S on TP = 4, Gemma 431B at 21.6 TOC/S, and Quen 2.572B at 14.9 TOC/S on TP = 4 PP = 2. Community feedback was blunt. llama.cpp with GGUF quants would outperform VLLM on V100S for most workloads, with one commenter reporting 45 TOC/S for Q, W, E, and 3.5122BA10B on 8x V100S via llama.cpp. The Altman Question. The New Yorker published what may be the most comprehensive profile of Sam Altman to date, drawing on over 100 interviews and previously undisclosed documents, including the Ilya Memos, 70 pages of Slack messages and HR documents that Sutskever compiled and sent as disappearing messages to fellow board members before the November 2023 firing. The memos allege a pattern of misrepresentation. Altman purportedly told the board that GPT-4 features had been approved by a safety panel when they hadn't, neglected to mention that Microsoft had released an early ChatGPT version in India without completing a required safety review, and privately assured different factions contradictory things about Brockman's role. A board member describes Altman as having two traits that are almost never seen in the same person: a strong desire to please people, to be liked in any given interaction, and almost a sociopathic lack of concern for the consequences that may come from deceiving someone. The article traces the erosion of OpenAI's safety commitments in granular detail. The superalignment team, promised 20% of compute, reportedly received 1 to 2%. Most of it on the oldest cluster with the worst chips. The WilmerHale investigation into Altman's firing produced no written report. Findings were limited to oral briefings shared with 2 board members, and some board members say they never received even those. Multiple administration officials expressed discomfort with Altman's geopolitical ambitions. A plan to build chip foundries in the UAE, a data center campus in Abu Dhabi 7 times larger than Central Park, and a $500 billion Stargate joint venture announced alongside Trump. A former OpenAI executive calls the UAE data center expansion the most reckless thing that has been done. Whether one views Altman as a visionary navigating impossible constraints or a pattern-matching dealmaker who tells each audience what they want to hear, the structural question remains. The person who may wield the most consequential technology in human history has systematically dismantled every governance mechanism designed to constrain him. Agentic coding hits the wall. A GitHub issue on the Claude Code repository has become the most data-driven critique of agentic coding regression to date. A user analyzing 17,871 thinking blocks and 234,760 tool calls across 6,852 session files documented a measurable quality collapse correlating with thinking content redaction starting in early March. The read-to-edit ratio. How many files the model reads before making changes. Dropped from 6.6 in January to 2.0 by late March. A 70% reduction in research before mutation. Full file rewrites doubled. A programmatic stop hook, catching premature stopping, responsibility dodging, and permission-seeking behavior fired 173 times in 17 days after March 8th. It fired 0 times before. The user's positive to negative sentiment ratio in prompts collapsed from 4.41 to 3.01. Most strikingly, the human sent roughly the same number of prompts in February 5,608 and March 5,701, but the model consumed orders of magnitude more tokens to produce demonstrably worse results. The user, running 50-plus concurrent agent sessions doing systems programming, was forced to abandon the multi-agent workflow entirely and retreat to single-session supervised operation. The counterpoint comes from a developer who spent 3 months building SyntacLite, a comprehensive SQLite DevTools suite he'd wanted for 8 years. His 250-hour retrospective is the most honest post-mortem of AI-assisted development published this year. The first month was pure vibe coding. Claude acted as designer and implementer while the developer managed. The result was a functional prototype with 500-plus tests. And complete spaghetti code he couldn't reason about, forcing a total rewrite. The second phase worked. He took ownership of all design decisions, used AI as autocomplete on steroids within a tight review loop, and shipped a parser, formatter, VS Code extension, Python bindings, and WASM playground. His taxonomy is precise. When you understand the problem deeply, AI is excellent. When you can describe what you want, but don't know the domain, AI is good, but requires care. When you don't even know what you want, AI is somewhere between unhelpful and harmful. The slot machine comparison recurs. The sunk cost fallacy, the tiredness feedback loop, the just one more prompt compulsion. That compulsion is now a recognized phenomenon. A lead dev article catalogs developers losing sleep to agentic coding. Not from deadline pressure, but from the dopamine loop of rapid iteration. Reddit comments paint a vivid picture. "I've done 7 all-nighters the last 2 months," one writes. Another describes ending up in therapy after a crash. The comparison to civilization's one more turn is apt, but the stakes are higher. Context splits between human and agent mean walking away risks losing the thread entirely, creating a perverse incentive to keep going until 5 a.m. Agent infrastructure, meta-learning harnesses, and desktop automation. AutoAgent takes the concept of agent engineering and turns it recursive. You write a program.md file that instructs a meta-agent, which then modifies the actual agent harness agent.py. Tools, prompts, orchestration, routing, runs benchmarks, checks scores, and iterates autonomously overnight. It's hill climbing on benchmark scores with Docker isolation, using the same evaluate, keep, or discard loop as auto-research. The harness is a single file with a fixed harbor adapter boundary and an editable everything else surface. The key design choice is that humans program the meta-agent's instructions, not the harness directly. A clean separation that keeps the optimization loop stable while the agent explores the design space. On the desktop automation front, Use Computer is a cross-platform CLI for AI agents built on a native Zig binary. Screenshot, mouse control, keyboard synthesis, all available as commands with no Node.js runtime required. It supports the screenshot act screenshot feedback loop with coordinate mapping, works on macOS Accessibility API, Linux X, 1.1/X, W, AYLAND in Windows, and ships with an agent skill that teaches Claude Code or OpenCode the correct workflow. The library API mirrors the native command shapes, making it trivially integrable as an OpenAI computer tool or Anthropic computer use backend. LightRag continues to prove that GraphRag doesn't require Microsoft-scale budgets. A tutorial walkthrough demonstrates the full pipeline. Docker Compose setup via Claude Code, OpenAI embeddings for knowledge graph construction, and Claude Code skills wrapping LightRag's API endpoints for seamless query/upload/explore from the terminal. The key selling point remains cost efficiency. A study cited in the video showed RAG being 1,250x cheaper than naive LLM context stuffing for large document corpora, though that figure is from July 2025, and the gap has likely narrowed. The practical threshold for when RAG pays off, somewhere around 5,002,000 text pages, where agent search starts losing coherence and cost explodes. CareerOps takes a different angle entirely. An AI-powered job search pipeline built on Claude Code that evaluates offers with structured AF scoring, generates ATS-optimized CVs per job description, and scans 45-plus company career portals via Playwright. The author used it to evaluate 740-plus job offers, generate 100-plus tailored CVs, and land ahead of applied AI role. The system is explicitly not a spray-and-pray tool. It filters ruthlessly, recommending against applying to anything below 4.0 fits. The design philosophy mirrors good agent architecture, human in the loop for all decisions, accumulating context over time interview story banks, negotiation scripts, and self-customization where Claude reads and modifies its own configuration files. AI meets cybersecurity, generalization, and the shortcut problem. A paper from Politecnico di Torino and Huawei tackles what may be the most persistent failure mode in cybersecurity ML, shortcut learning. Models that achieve 92% plus accuracy on random splits crater by nearly 30% on temporal splits, where they must classify attacks they've never seen variants of. The authors propose some semantically aligned language models, a 2-stage contrastive learning framework. Stage 1 restructures an LLM embedding space around 15 vulnerability types using contrastive learning on textual CVE descriptions. Stage 2 freezes the text encoder and trains a payload encoder to align raw HTTP payloads to that same space via cross-modal alignment. At inference, classification is pure semantic retrieval. Embed the payload. Compare cosine distance to textual prototypes like SQL injection attack. Prototypes the model never saw during training, forcing genuine generalization rather than memorized patterns. SALM reaches 68.1% accuracy on temporally shifted private data versus 62.3% for fine-tuned CodeBEARD, with the improvement concentrated on mid-frequency classes where lexical cues are unreliable, but textual descriptions provide clear semantic grounding. The approach also opens a zero-shot pathway. Add a new vulnerability type by specifying a text description, no retraining required. The gap between 68% accuracy and production-grade reliability is wide, but the direction. transferring knowledge from data-rich text modalities to data-scarce payload modalities, addresses the fundamental asymmetry that makes cybersecurity ML so fragile. On the practical tooling side, ICE-T is a Go-based SAS scanner combining tree-sitter AST pattern matching with optional LLM reasoning for false positive filtering. It ships with 82 built-in skills covering 456 plus detection rules across 12 security domains: auth, injection, web/API, crypto, file system, infrastructure, logging, memory safety, cloud, Android, network, supports 10 languages and outputs Sarif 2. 1.0 for GitHub integration. The extensibility model is notable. Add detection rules via Markdown plus YAML files with no Go code required. Its 3-engine architecture: pattern matching, taint tracking, LLM verification, represents the emerging consensus that pure static analysis and pure AI scanning both fail, and the hybrid approach is the way forward. Post-quantum cryptography. We need to ship. Filippo Valsorda, one of the Go standard library's cryptography maintainers, has publicly shifted his position on post-quantum migration urgency, and the shift is dramatic. 2 recent papers catalyzed the change. Google revised down the estimated logical qubits needed to break 256-bit elliptic curves P256. Is Sec 256K1 enough to make attacks feasible in minutes on fast clock architectures? And Oratomic showed it could be done with as few as 10,000 physical qubits given non-local connectivity. Google's Heather Adkins and Sophie Schmid have set 2029 as their deadline. Scott Aronson's clearest warning draws an analogy to how nuclear fission research stopped being public between 1939 and 1940. Valsorda's framing is blunt. The bet is not, are you 100% sure a CRQC will exist in 2030? The bet is, are you 100% sure a CRQC will not exist in 2030? The practical implications are severe. Any TLS connection without MLK, key exchange should now be considered a potential active compromise. Hybrid classic plus post-quantum authentication makes no sense anymore and will only slow deployment. Go straight to pure LDS A44. New non-post-quantum schemes should simply not be deployed, period. Hardware attestation systems: Intel SGX, AMD EV, SNP are just FD. Their root keys are not PQ, and there's no progress on rolling out PQ replacements at hardware speeds. File encryption is especially vulnerable to store now, decrypt later. Symmetric cryptography gets a pass. 128-bit keys remain sufficient because Grover's algorithm doesn't parallelize. Valsorda has started teaching a PhD cryptography course at the University of Bologna, where RSA, ECDSA, and ECDH are introduced as legacy algorithms, because that's how the students will encounter them in their careers. Model ecosystem. Qwen 3.6, OmniVoice and single-step generators. Alibaba's Qwen team released QWEN3.6+, positioning it as a critical milestone toward native multimodal agents with emphasis on agentic coding. Community reaction is mixed. The benchmarks look strong against GLM5, Opus 4.5, and Gemini 3 Pro. But commenters note the conspicuous absence of GPT 5.4 and Opus 4.6 from comparisons, and the team admits to correcting problematic tasks in SW Bench Pro before evaluation. Open-source smaller variants are promised in the coming days. OmniVoice, an open-source TTS system supporting 600-plus languages with voice cloning, is generating excitement for its quality-to-size ratio. Early testers report 12x real-time generation speed on a 5090. Insanely good voice cloning even for non-English languages, and expressive tags that make output sound alive. At about 6.5 GB VRAM, it sits in a practical sweet spot for local deployment. The main gap: inference still requires torque audio, with no lightweight C++ runtime yet. Andrea Burkhoff highlighted a paper that eliminates iterative denoising from image generation entirely. Instead of running a neural network dozens of times to gradually clean noise into an image diffusion's core mechanism, the authors define a drifting field that lets training itself do the distributional work. The network is a single-pass mapping from noise to data. The result, 1.54 FID on ImageNet 256x256. Better than all prior single-step methods and competitive with multi-step diffusion models that run hundreds of passes. The detail buried at the end. The framework also works for robot control policies. Hints at how general this approach really is. Single-pass generation from complex distributions is not just an image technique. It's a paradigm.